Hello, everybody. My name is Diana, and I'm a biomedical engineer and web accessibility expert. And this is the webinar Creative Coding for Children. So I will tell you how to do it in the best way, the most creative, the most informative, and how to explain coding and languages um, as close as possible to real life examples and how to solve the problems from life, real problems using coding. First, I will tell you a little bit about myself and my experience. So I will share with you my presentation. I hope it will be seen. Here it is. And so my name is Diana, like I mentioned, and I studied in several universities. I have a degree in biotechnology. Um, and I spent 6 years of my professional life working as web developer. Then I studied web accessibility. And here I am. I worked for many years as um, not only as web developer, but I have my project Totilo, where I explain what is coding and what is accessibility, how to apply to your projects. So I had a lot of questions from the parents, how to keep the interest in coding and how to explain it in the best way. And that's what I will tell you. Um, so yeah, first I would like to tell you a little bit about um, biotechnology because I believe that the answer to the question how to teach coding in the most creative way is that there is just one answer, to be as close to real life examples um, as possible and to explain coding and technology and innovations based on what's around us and what actually connects us to this life and to this world. And I would say that health and environment, these are very good parameters, very interesting ones. So I usually start when I talk to children, I start by explaining about our body, about what's around us, even the air that we're breathing, how it affects us, because these parameters, they really connect us with life and makes us interested in what's going on, how our body function. These, all of us, we have it, and we all have some problems or questions about our body. So this could be a very good beginning. Um, this I just with this slide wanted to explain that the knowledge that they get with the biotechnology, it can be applied in different spheres and in different companies. So it also has a practical result. Yes, this I will just go straight to the optimal environment parameters. So I just would like to share with you and to just tell you some interesting facts about what should be the optimal parameters for our health. Like, for example, the optimal indoor air temperature, it's between 18 and 22 degrees. It shouldn't be too high or too low. And this is the sensor with which we can get this information. I will try to, no, I think I don't have it with me. Unfortunately, I have some sensors with me to show you. Um, yeah, well, I don't have the temperature sensor with me, unfortunately, but I have other sensors that I will show you. This is the same sensor, yes, about the humidity of the air, and it should have particular level. Otherwise, our eyes will become scratchy and they will be irritated and it will be harder to work. This is the concentration of CO2 in the air, and this is the sensor that I have that help us to get this parameter. This is the sensor to get the light level, and um, I don't have it somehow. but I actually found the previous sensor. Sorry. Sorry. It's here. Yes. So this is the sensor with which we can get the temperature and humidity level. And so this is the luminosity level, the sensor that can help us to get this parameter. And this is the sensor for the, this is literally a microphone. So this sensor can recognize what is the level of decibel in the air, the sound wave. And that's how it looks. This is just interesting way to show that, okay, there are some parameters in our body and outside, and there are special devices that can get the parameters, the levels of these parameters, and then we can use it. It's important to see that they're physical, that they're real, that we can touch them, we can work with them. And it's the same about parameters of our body. And for example, it's about body temperature. I'm trying to find the temperature sensor to show you. I think I saw it, but yes, like I have such small, it's also a temperature sensor, and different devices, electronic boards with which we can code, they also contain a parameter, so they can show the temperature. And like, for example, this is the Microbbe, the electronic board, and it has on it the, it can show the temperature of the air, but it's important to remember how exactly the parameter is taken. Like here, for example, the device is taking the temperature of its processor. So it takes the temperature from the processor and shows it as the temperature of the air. Okay, so here is the heart rate, and I have this sensor to show you. So here it is. Yes, and like this, we can see the heart rate, and it should be between 55, 85 normally. Of course, not after running, but yes, this is for just optimal life being. Also, step counter. This is quite interesting. So we're talking about the accelerometer. This is the device that we have, for example, in our phones, like even in mine, like you probably noticed that when you're on the phone, so it has a special uh, vertical way of plastic, putting the objects, like putting the elements in the web or of your phone, but when you turn, it automatically changes it to horizontal one. And this is because of the sensor accelerometer. With this sensor, we can also check if it shakes, so we can recognize that you make a step, that you step with one foot, and it counts as one step. And like this, the devices like electronic watches, smart watches, they recognize how many steps you do per day. This is the same, actually, the same sensor accelerometer, but it can show whether you move during your sleep. Again, it's about the shaking, it's about the change in the space of your body. And like this, we can see whether you're sleeping or you're awake. But you can use many different devices to do this. And here is a very interesting sensor. I saw it here. I have a lot of sensors with me today, sorry. So this is the motion sensor, and we can use it to detect as well the position. But here it's about the slightest, it's more like working like a signalization in your house, like it becomes red, or like that could become red, or some, like with the slightest movement, it shows that yes, there is activity. So this is the sensor that can help to stay active, and to remind that you need, for every 1 hour or 1.5 hours of work, you need to move for 10-15 minutes just to stay active so that your body moves, the blood moves in your body, and you stay healthy even while you're working. Okay, this is just a small slide to recognize what you think is the best combination of parameters for your health. And we can check like high air temperature. I think this is not really optimal. Higher humidity is important, and high CO2 is also not so good. While low air temperature, yes, this is better. Higher humidity, it's also good, but high CO2, this is not good because like this, it's harder for us to work. It doesn't provide a lot of oxygen to the air, and also CO2 particles, they are quite easy for viruses to attach, so it's much easier to get ill. That's why it's important to open the window and let fresh air in. And the best combination is low air temperature and higher humidity and low CO2 level. And now we'll show you after this slide some, I will just change a little bit, and I will show you what else I use for creative coding for children. And this is the game that I created. So it's called Health Tech Heroes, and there are three types of parameters, three types of options. So there is a software, hardware, and parameters which contain body and environmental parameters that I was just talking about. And having a combination of these options, we can create a project that can solve almost any problem. Like, for example, if we have a headache during the evening, the child can have, for example, a problem sitting in front of the computer, or having a problem, I don't know, with the arm working on the computer, on the keyboard. There can be different situations. The most important is to ask what the child is interested in or which problem he would like to solve. But for example, like what I already started, if like some people, they have it, and if there is a problem with the headache during the evening, so we should go from the fact like, okay, what are the parameters that correspond to this state? And it might be CO2 level or high temperature, because by the end of the day there are most probably a lot of people inside the house, and there might be higher CO2, so these parameters should be checked. And how we can check it? We can check it with hardware devices, like, for example, with the sensor that I already showed, CO2 sensor, and the temperature can be checked with the temperature sensor. With these two sensors, we can check, we can connect it to the electronic board. For example, to Arduino electronic board, we connect it to these outcomes, and we get the data. But it's important that how we get the data, when we just connect physically the sensors to the electronic board, this will not be enough. We need the language, we need to speak the language that the device is speaking. In this case, it's C++. So we need to create a program that will tell, okay, you take these two sensors, you get the data from them, and then you display it there. And like this, so we have parameters, hardware, software. And the software, I mean programming language, and the software that you use in order to create the code, to connect the parts of the code in case if you use blocks, and then you transfer it on the electronic board and it works. So like this, with easy example, we can get the parameters, see, oh, maybe yes, the CO2 level every evening is quite high, so we need to remember about this and to open the window to refresh and to increase the level of oxygen in the room. And I think it might be a high reason that the person will feel better and there will be no headaches. Now we'll be back to my presentation. I will show also a small example, just like what I said, but mostly on the practical examples, like another program, another problem that we can solve using this method. Okay, so I will again open the presentation. And here's the electronic board that I already showed. There it is. It again, everything is moving away. Here it is, the Microbit, and that's how it looks. So there are different types. It's like a mini computer, and it has its own processor. We don't need to be always attached to the computer with this electronic board. We can use the battery set, so we just plug it here, we connect it, and we can be autonomous during the day, and we can still get the data. Yes, and we have a display. That's why it's very practical and easy as the first electronic board to use. Well, first, it actually understands the language microbit, which is the easiest for the beginners. And second is that, for example, electronic board Arduino, it doesn't have a display. So we need to attach another sensor with the display in order to show the results of the sensors. Okay, now we will move. So this is the Micropython, what I mentioned. So each electronic board understands its own language, and in this case, it's Micropython. And how it looks. This is the second parameter, so you can see that's exactly how Python code look like. What is the difference? So sometimes I say Python, sometimes I mention Micropython. So the difference is that Micropython is just the part of Python. They just use more minimalistic, like simple functions. But if you understand Micropython, you will understand Python. And Python is used for many applications. It's widely used by developers, so it's very good thing to know. And now we'll show you the program with microbit. So just if we want to take room temperature, I was already showing the sensor with which it's possible to do it, but we can be without any sensors. We can be just with this device, and this will provide us temperature automatically. This is very convenient. Yes, it might not be very precise. As I mentioned, it shows as a temperature the result that it gets from the processor. But still, for the first program to get the temperature, even if it's like a little bit different from the not extremely precise, but still it provides a result which is close to reality. It's already amazing, and we don't need any sensor for it. And how we're gonna do it, I will show you how to create the code. So we go straight to the software because, okay, we have the hardware and we know that we try to get temperature parameter. So I go to the site Vitasians, and I go to the programming interface for Microbit. So there are already blocks, like programming blocks that contain elements of the code, the parts. So it's very interactive and it's very visual way of learning the language. So it's very good for children as the first step. And here, first I create the letter T that represent temperature to display on this 25 LED screen. And then here we will see also the temperature level. So that's the code. And you can see that while I was changing, on the right side, there was the code which was changing. Don't worry, I will show you very closely what exactly I did. So we see that that's how we create the image that will be on the LED display. the T, and then I add the pose, not to overlap two images on the display. And then I show a temperature level that Microbit takes automatically from its processor. And then I say again, okay, we wait 1 second, we just don't overlap, because it's a while true loop, forever loop. So the process of providing the temperature level will be forever, for as long as the microbit is has any energy, whether from the batteries or connected to the computer. So now I will go even deeper, and I will show you every line of the code and what it means. So we say, okay, we will work with the microbit. So we import the libraries from Micropython, specifically the ones that will be needed to work with microbit. Then we import the time module into the program, and we start the cycle of repetition. So this is a loop to repeat the code multiple times for as long as the microbit is connected. This is very interesting. So there are a lot of numbers, and you might be confused what it means, but 9 means that the LED is turned on. 0 means that it's turned off. And as you remember, letter T, so on the top, it's just the line. So all the LED should be turned on. And that's the first part with the 5, 9. Then we see 0, 0, 9, 0, 0. That's where it starts to go down. Like this is the line just under, where there is just the middle part starts, and that's how it is. That's how the image can be created, just with 0 and 9. Then we say, okay, display the image on the screen. Then we add the time model, the pause, and then we display the temperature level that is taken from the microbit. So we display this value directly on the LED screen. And then again, I add a pause of 1 second. And I will show how it works. Like the display will show you the values of what we just created, like the working code. And we will see both the letter T and the temperature level. So it shows that there are just 19 degrees. And like this, we can get all the information. We can also build phrases. We can provide really big values. It's not a problem, as you can see. And there are different ways of just displaying the information. It can be just one after another, or it can be like in the trains, maybe you see the way it moves from the left to right, from the right to left, sorry. But I guess it also depends in which country you are. So that's how it works. And this is very simple, very efficient. It helps to develop the brain, because we need to think logically in order to build the code. And it has a practical meaning. We can get the temperature in this room right now. It's not something that we are not using. No, we can check. We can say, oh, it's actually makes sense why it feels so cold, because it's cold. Like, for example, yes, yes, and based on this, we can already go forward with different sensors that are already built inside the microbit, so we don't need any extra sensors. And we can already have such programs like step counter, fall measurement, effective teeth cleaning meter. Like we can count the way how you brush your teeth, because it's shaking, so it's connected to accelerometer, which is already built in the microbit. Measurement of physical activity, or we can also have mini station, because inside the microbit there is a microphone. There is also a luminosity sensor, so we can check 3 parameters: temperature, light, and sound, using just this device. And this is already a complex project. So that's how it works, and that's how creative coding for children look like. And I hope that this will help you to make your child more interested and keep this interest in the science and technologies, and coding is just the beginning. Thank you for being on my webinar, and hope to see you soon.